Hi, this is coordinate geometry number 9, distance in the coordinate geometry system for accelerated geometry. So there are a lot of slides in this one, and I'm going to go pretty quickly through them because you'll have a copy of this probably on your own to look at anyway. And it's not that difficult. I think it's stuff that you've already had in Algebra 1, the distance formula. Okay, so let's start out, and it says there's a person named Isabella, and she's standing over here on the corner of 7th Street and 8th Avenue, and her sister Kaylee, here in K, is on the corner of 2nd Street and 3rd Avenue. To find her shortest sidewalk route to Kaylee, Isabella can simply count blocks. But if Isabella wants to know her diagonal distance, she would need the Pythagorean theorem. So what they're saying is Isabella can get to Kaylee by counting 1, 2, 3, 4, 5 blocks plus another 6, 7, 8, 9, 10 blocks. But if they want to go diagonally across somehow, like the bird would fly, you'd have to use the Pythagorean theorem. Okay, you can think of the coordinate plane as a grid of streets, it says. And if you want to find this distance, you can make these triangles. So I can, from the end here, make a vertical line, and from the end here, make a horizontal line. And then I could actually use the Pythagorean theorem to find how long this side is. And there's all other examples here. So if I want to find how long this line is, I do a vertical line from there, a horizontal line from there, and I create a nice right triangle, and then I can say 2 squared plus 1, 2, 3, 4, 5, 6, 7, 8 squared is equal to whatever that line here is squared. Okay, so then they're going to do the same thing here. So here is a line, that red line that I want to find the length of, and they say let's make a right triangle. So they come down here and they go over here with a vertical line and a horizontal line, and they create a right triangle. And then in that right triangle, you can look at it and count the sides. So this side is 4, and this side is 2. And so 4 squared plus 2 squared is equal to the distance squared between those 2 points. So 16 plus 4 is equal to d squared. 20 is equal to d squared. And then if I take the square root of each side, I'd have the square root of 20 is equal to d. 20 is 2 times 10. 10 is 2 times 5, so it's 225. And the 2 2's then can come out, and there'd be a 5 left inside. So that is the answer in simplest radical form. And then they do a whole bunch of these other ones. So I'll do one more, and then we'll skip the 2 after that. So that if you want to know that red distance, the distance between those 2 points, which are at 1, 3, so this point here is at 1, 3, and this one is at 7, 5. If I want to know the distance between 1, 3 and 7, 5, you can make a right triangle by coming down and going over. 2 here and 6 here, and then I can use Pythagorean theorem. 6 squared plus 2 squared is d squared. 36 plus 4 is d squared. Square root of 40 is d, because it's 40 is equal to d squared. Take the square root of both sides. Square root of 40 is equal to d. 40 is equal to 2 times 20. So here's that 2. 20 is 2 times 10, so that's that 2. 10 is 2 times 5, so I could have made a tree, but I just did it like this. And now those 2 2's are going to come out as a 2, and the 2 and the 5 are going to stay in as a 10, so that's the answer in simplest radical form. And there are 2 more examples like that. I'm not going to go through all those. If you wanted to look at them, you could. Then it says look at the example B again. The endpoints are 1, 3, and 7, 5. How could you use just the endpoints to find that the horizontal distance was 6? So if I want to know this horizontal distance when I make this right triangle, the horizontal distance here, if this is at 1, 3, and this is going over 7 and then up 3, the distance would be 7 minus 1, and that would tell me that that side is 6. And then how can you tell the vertical distance? Well, this vertical distance is this, so it's 7, 5, and this one is 7, 3. So the distance between 7, 5 and 7, 3 is just 5 minus 3, the y value is subtracted. So the horizontal distance where the x value is subtracted, and the vertical distance where the y values subtracted. So that's what this is saying. Write an expression for the length of the horizontal leg using the x coordinates. Okay, if this is x sub 1, y sub 1, and that is x sub 2, y sub 2, I should probably see if I can get a pen going here. So, yep, I do. So this would be going over, oh, I can't write on here. Okay, so anyway, I'll skip that. This is the point, x over x sub 2 and up y sub 1. Okay, so what would the distance be? This would be x sub 2, as long as x sub 2 is, subtracting off x sub 1, that would be the horizontal distance, and the vertical distance is going all the way up to y sub 2, and then over here it'd be up at y sub 1, so the vertical distance would be y sub 2 minus y sub 1. So now they say, generalize this. What could you get as a Pythagorean theorem if I had to set it up in that form? So I would say that distance d squared is equal to this horizontal distance x sub 2 minus x sub 1 squared plus this vertical distance y sub 2 minus y sub 1 squared. And then solve for d, so I take the square root of both sides. So d would be the square root, big square root of that whole right-hand side. So the distance between points A at x sub 1, y sub 1, and B at x sub 2, y sub 2 is given by the distance formula. D equals a huge square root of x sub 2 minus x sub 1 in parentheses squared plus y sub 2 minus y sub 1 in parentheses squared. So that should go on your conjecture list. And here is an example of this now. Given just the endpoints, find out how long the segment would be that connects those. So I would take x sub 2, which is 11, minus x sub 1, which is a negative 1. Notice that, minus this negative 1. And then the whole parenthesis would be squared, plus y sub 2, which is a negative 7, minus y sub 1, which is a negative 2, all in parentheses squared. So that would be 11 plus 1 and a negative 7 plus 2. And when I square it, that would be 12. It's going to be 12 squared, and negative 7 plus 2 is going to be a negative 5. So that's going to be a negative 5 squared. So 12 times 12 is 144. Negative 5 times negative 5 is 25. So that's the square root of 169, which actually turns out to be a cute little 13. And then there's another example here. And I'm not going to go through that one. Then there are a few other examples. Is the quadrilateral with vertices at 0, 2, 1, 5, 5, 3, and 4, 0 rectangle. So the solution to this says, well, let's look at the length of these sides. So they use the distance formula, except that they don't do it very well because they told us the distance was the big square root, and now they're just saying distance squared equal. So that's kind of unfortunate, but anyway, when they use the distance formula, they have the square root. It would be the distance equals the square root of all this, square root of all this, so it'd be the square root of all this, so it'd actually be the square root of 10. And then, using the distance formula again, they find that CD is also the square root of 10, so those would be sides that are equal. And then AD they find out to be 2 square root of 5, and BC they find out to be 2 square root of 5. So those sides are equal. So that would be nice for a rectangle, but are those angles right angles? So they find the slope of AB and the slope of BC. And if those are going to be perpendicular to each other to form right angles, they would have to be opposite reciprocals. And they are opposites, but they're not reciprocal. So therefore, in that figure, it's not really a rectangle, even though the opposite sides are equal. The angles are not 90 degrees. What is the area and perimeter of triangle LMN? So it says to find the perimeter, you have to use the distance formula to find the length of each side of the triangle and find the sum. So there is the perimeter by adding all of these up. So this is side MN. They go through the distance formula and get a 5. LM, they get 4 square root of 2. LN, they get the square root of 17. And so when you add those all together and then put them in your calculator, you get 14.78. So that would be the perimeter. Now, to find the area, this is kind of a little trick here. And this doesn't happen all the time. It's just that it's a nice triangle. Look what they do. The area is 1/2 base times height. So they find a base and a height that are perpendicular to each other that they can count. So if I use this base, MN, I can count 1, 2, 3, 4, 5 units. And if I go from this vertex down here perpendicular, I can actually count that height to 1, 2, 3, 4. So using that, I can now say it's 1/2 5 times 4, which turns out to be 10. Now that would not work at all if I use this side and then this as the altitude that came down there, because I can't count them. So that's why I say it only works on special triangles. Okay, what is the 4th vertex of this square? So this is just kind of looking at it. It would probably have to be right there. What is the length of the diagonal of the square? So the diagonal of the square would go from 0, 0 to 3, 3. So they use the distance formula, 3 minus 0 squared plus 3 minus 0 squared, 3 squared plus 3 squared, 9 plus 9, square root of 18. That's 18 is 2 times 9, and 9 is 3 times 3, so it'd be 2, 3, 3. So the 2 3's would come out and the 2 would stay in. A map is located on a coordinate grid. Jacksonville is located at 5, 4, and Janesville is located at 2, -3. How far apart are those on a map? And this says each unit actually represents 10 miles. So how far apart would they be in reality? So here's the distance formula. So I'm subtracting the x's, 5 minus 2. And then I put that in parentheses with a square. And then the subtraction of the y's, 4 minus -3. Put that in parentheses with a square, and then take the square root of that whole side, or that whole thing. And then here, this would be a 3 squared, which would be a 9. And this would be a 7 squared of 49. Square root of 58 would be 7.62 of those units. But then each of the units represents 10 miles. So I'd have to take that answer, 7.62, and multiply it by 10. So that is the end of the lesson on distance in the coordinate geometry system.